When you've completed this lesson, you should be able to write decimal numbers in scientific notation and also be able to write numbers that are in scientific notation back into decimal notation. Photonic technicians need to use very large and very small numbers. So to write these numbers into a calculator or a computer, we need to use scientific notation. For example, for the speed of light, rather than writing 30 billion centimeters per second, we'll use the number 3.0 times 10 to the 10 centimeters per second. Or for Planck's constant h, rather than all of those zeros followed by 6625 joule seconds, we can use the number 6.625 times 10 minus 34 joule seconds. We will learn in this module how to write those numbers. Now, let's take a look at an example problem. Suppose your supervisor asks you to calculate the energy of a photon from a certain laser. You know that the formula for the energy is E is equal to hc over lambda, where h is Planck's constant, c is the speed of light in a vacuum, lambda is the wavelength, and E is the energy in joules. You'll notice that those first three constants are all given in terms of scientific notation. They are either very small numbers or very large numbers. You'll have to use scientific notation to make those calculations. In this module, you'll learn how to do that, but we'll return to this problem involving scientific notation later. Now, scientific notation is essentially a way to write numbers that are very large or very small. So let's recall some powers of 10. 10 to the 1, for example, is 10. 10 to the second power, or 10 squared, is 10 times 10, which is equal to 100. 10 to the fifth power is 10 times 10 times 10 times 10 times 10, which is 1 followed by 5 zeros. Do you see the pattern here? That's going to be our secret as we continue along. So a few definitions and terms are important for us. Scientific notation is a prefix followed by a base and an exponent. The prefix is a number between 1 and 10, but not including 10, followed by the power of 10, which is the base, which is always 10, and an exponent, which is the integer up at the top. The prefix and the exponent can be positive or negative. So you can have negative 3.14 or positive 3.14. You can have 10 to the negative 11 or 10 to the positive 11, as you see in those examples here. So let's write some large numbers. We can write any large number as a prefix times the power of 10. So, for example, 100 would be 1 times 100, which is 1.0 as a prefix times 10 to the 2. 150 is 1.5 times 10 to the 2. 3,750 would be 3.75 times 10 to the 3. Or 37,500 would be 3.75 times 10 to the 4. So how do we determine that 10 to the 4th? We start by determining how many places we have to move the decimal point to get the prefix between 1 and 10. We see here that we had to move the decimal point 4 places, so that became our exponent. So let's recall that very large number. Do you remember the 314 billion? In that case, we have to move the decimal point 11 places in order to get the 3.14 prefix between 1 and 10. So that gives us the number 3.14 times 10 to the 11th in scientific notation. Now, we can also write very small numbers in scientific notation as a prefix times the power of 10. So 0.1 is the same as 1 times a tenth, which is 1 times 10 to the negative 1. Notice that 1/10 is the same as 10 to the minus 1 power. 0.01 is the same as 1 times 100th, and 100th is the same as 1 over 10 to the 2, which is the same as 10 to the minus 2. .015 is 1.5 times 1/100th, or 1.5 times 1 over 10 to the 2, or 1.5 times 10 to the minus 2. So, do you remember that very small number, the 314, preceded by lots of zeros? In the same way, we can count how many places we have to move the decimal point to get to that prefix, and we have 3.14 times 10 to the minus 7. So we can write large and small numbers. Large numbers have positive exponents like the speed of light is 3.0 times 10 to the 8 meters per second. Cordless phone frequency is 2.4 times 10 to the 9th hertz. In our galaxy, there are lots of stars, about 5 times 10 to the 11th stars. Or we can write small numbers that have negative exponents like the wavelength of a laser light is a very short distance of 6.1 times 10 to the minus 6 meters. Or the clock cycle of a supercomputer is a very short amount of time, 2.6 times 10 to the minus 13 seconds. And the mass of a proton is 1.7 times 10 to the minus 27 kilograms. Very small weight. You're probably wondering, why do we call it scientific notation? Well, because engineers, technicians, and even scientists often work with very large and very small numbers. So we had to come up with a way to put those numbers into a calculator and computers, and it makes it much easier to manage and put them into tables and references. It's often necessary since most computers and calculators are limited to about 10 digits. Later, we'll see a slightly modified version of scientific notation called engineering notation. So how do we write numbers in scientific notation? First of all, locate the decimal point. So in 81,000, the decimal point is right after the last zero. Count how many places you have to move the decimal point to the left. In this case, we have to move it 4 places to get the prefix between 1 and 10. And the number of places we have to move the decimal point becomes our positive exponent. So we have 8.1 times 10 to the 4th. If we do a check, 8.1 times 10,000, which is the same as 10 to the 4th, and we get back our original number of 81,000. So we're confident that we've done everything right. To write small numbers, as before, we locate the decimal point, which is right before the point 0715. We count the number of places this time to the right in order to get the prefix, which is between 1 and 10. In this case, it's 2 places to the right. And the number of places becomes our negative exponent in this case. 7.15 times 10 to the minus 2. So we have our number with our new decimal point location and the power of 10 with our exponent of minus 2. As before, we should always check our work. 7.15 times 10 to the minus 2, which is the same as 0.01, which yields 0.0715, our original value. So now we're confident that we've done our work correctly. Here are some more examples of some very large and small numbers that we can write in scientific notation. Notice that each one is a prefix between 1 and 10, multiplied by a power of 10. Engineering notation is just slightly different from scientific notation because the exponents are always multiples of 3. So for very large numbers, our exponents will be 10 to the 3 power, 10 to the 6th power, 10 to the 9th power, or 10 to the 12th power, and so on. And you'll notice that those conveniently correspond to the prefixes that you're used to seeing in the metric system, such as kilo, kilometers, or kilograms, mega, megahertz, or giga, tera, and peta. And similarly, for small numbers, we have 10 to the minus 3, minus 6, or minus 9, and so forth. And those also correspond to metric prefixes that you've seen for the small numbers, as in millimeters, micrometers, nanometers, picometers, and so on. Comparing scientific notation and engineering notation as shown in Table 2 in your text, you'll notice that sometimes you'll need to convert from scientific notation to engineering notation. If we have a number like 3.5 times 10 to the 4th, to convert that to engineering notation, to get the exponent to be a multiple of 3, we're going to have to change 3.5 to 35. Or another example, 8.4 times 10 to the 8th. To get that 8th into a multiple of 3, to go to 6, we'll need to change that 8.4 to 840, and so on. In each case, the prefix in the scientific notation is always between 1 and 10, but in the engineering notation, you'll notice that the prefix can be between 1 and 1,000. So how do we do that conversion? Let's look at an example. Suppose we need to convert the speed of light to engineering notation. 2.998 times 10 to the 8th meters per second. First of all, you'll notice that it's not an engineering notation. 10 to the 8th, the exponent 8, is not a multiple of 3. So we'll need to round the 8 down to the nearest multiple of 3, which in our case would be 6. In order to do that, we would need to divide 10 to the 8th by 100 to get 10 to the 6th. So we would have to also multiply the prefix by 100 to keep the same value. So we'll multiply the prefix by 100 and divide the exponent by 100. So we'll end up with 299.8 as the prefix and 10 to the 6th as the base and exponent as our number in engineering notation. Now, using a scientific calculator, you'll have to watch for the exponent key. It will vary on different calculators. You'll either have the EE or the EXP, or in some cases, just an E key. So to enter the prefix, for example, with an EE key, to enter 9.87 times 10 to the minus 6, you would enter the digits 9.87 like you would normally enter them, and then press the EE key for the exponent. In our case, you would enter the plus or minus key to get the negative in there, and then the 6 key. Now, you have to be very careful to note that the negative exponents use a negative sign, not a subtraction sign on your calculator. The calculator answer you get will also be shown in scientific notation. So it will look like 1.171 with a negative 94, or 3.72 with an E and a negative 16. Notice that the negative symbol tells you that it's an exponent of 10 to the negative 94 or 10 to the negative 16. If it was just a space, it would be 10 to the positive 94 or 10 to the positive 16. You'll have to look very carefully and be aware that the number will be in scientific notation. To do math with your scientific calculator in scientific notation, enter the values with the exponent key and then do the operation as usual. The result may also be displayed in scientific notation. Let's return now to the problem that we saw at the start of this lesson. There's our formula, with the numbers in scientific notation substituted. First of all, we can analyze the units. We'll notice that the seconds, joule seconds, will cancel with the meters per second. The seconds will cancel. and the meters in the meters per second will cancel with the meters in the denominator. So we're left with just joules. Now we can proceed to calculate the value with our scientific calculator. Enter the expression in your calculator, as shown here for a TI-83 or TI-84 series of calculators. So you would enter 6.625 followed by the exponent function and a negative 34 times 2.998 and the exponent function, and the power of 8 divided by 1.064 and the exponent function, and the exponent of negative 6. Then you press the Enter key to complete the evaluation. In the TI-30 series of calculators, you would enter a similar evaluation followed by the equal sign, and the result will be 1.8667 with e to the minus 19, or 1.8667 just with a negative 19, indicating that the answer is 1.8667 times 10 to the minus 19 joules, the answer in scientific notation. And we can also convert joules to electron volts by multiplying by unit ratio 1.867 times 10 to the minus 19 joules times 1 electron volt per 1.602 times 10 to the minus 19 joules. The joules will cancel, leaving us with electron volts, and if you enter that expression into your calculator, you will get 1.17 electron volts. Now, let's look at some of the practice exercises that are offered for you in this module. We'll not solve every one of your practice exercises, but we'll go over a few to give you the confidence so you can solve the rest of them yourself. For example, to change large numbers in scientific notation. The average distance of Earth from the Sun is 92,960,000 miles. Well, how would we express this number in scientific notation? As you've seen, you would find the decimal point. Move it over to form a prefix that is between 1 and 10. In this case, 9.296, we'd have to move the decimal point over 7 places. So that becomes our exponent. And our number in scientific notation then is 9.296 times 10 to the 7th miles. In summary, we locate the decimal point, count the number of places we had to move the decimal point. That becomes our exponent. We write our prefix decimal point after the left digit. And we now have our scientific notation. Exercise 2 asks you to change small numbers to scientific notation. So, for example, we can have 1 atomic mass unit, which is that very small number with lots of zeros, followed by 166 kilograms. We can write that number in scientific notation by counting how many places we have to move the decimal point over to get a number of a prefix of 1 and 10. In this case, we have to move it 27 places to the right. So that becomes our exponent of 10 to the minus 27 kilograms. So again, in summary, we locate the decimal point, count the number of places to get left of the digit to get a single left digit, write the prefix with the decimal point after the left digit, and the exponent becomes the power of 10 with that number of places and a negative sign, in this case because we had to move the decimal point to the right. We can do the reverse by changing large numbers that are in the power of 10 notation to decimal notation. For example, the speed of light, 2.998 times 10 to the 8 meters per second. If we wanted to write that number in decimal notation, 2.998, and we have to move the decimal point over 8 places. Then we have to insert some commas to make it more readable. In general, we locate the decimal point, For positive exponent, we move the decimal point to the right that number of places, adding placeholder zeros, if needed, as we did in this case, and insert some commas to assist in the reading of that very large number. We can change small numbers in power of 10 notation to decimal notation, such as Boltzmann constant of 8.617 times 10 to the minus 5 electron volts. By changing the 10 to the minus 5 to 1 divided by 100,000, and we're going to do just the opposite. We are going to take that decimal point and move it over to the left this time. By how many places do you think? 5 places, right? And we're going to insert some zeros to make that decimal point stay out there and add a 0 in the beginning before the decimal point. In summary, we're going to locate the decimal point, move the decimal point to the left, the number of places of that exponent, inserting placeholder zeros if needed, and insert an additional 0 before the decimal point so that when we read it, we say 0.00008617 electron volts. Now in general, we have some other numbers we would like to complete the prefix to change the number to the power of 10 notation. That may not be scientific notation. It may just be some other power of 10 notation, and if we want this to be times 10 to the 9th. In this case, we have to move the decimal point over 9 places. And in this case, it becomes 13.996 times 10 to the 9th. And you can see how that works. I believe you can convert most any number by moving the decimal point over the correct number of places. And you have to put some placeholder zeros if necessary. So for small numbers similarly, we have to move the decimal point over 9 places in this case. We may need an extra 0 to hold it out there. So you'll see that our answer will become 1,260 times 10 to the minus 9. And we did need that extra 0 in this case. All right, so how do we use a calculator to make some calculations? Let's try it with Einstein's equation of E is equal to mc squared, where mass is equal to 4.61 times 10 to the minus 6 kilograms. And c, the speed of light, is 3.0 times 10 to the 8th meters per second. Well, on a TI-80 series of calculators, that would be 4.61, then enter the exponent of negative 6 times 3, enter the exponent of 8, and in this case, we want to do the operation of x squared. Then press enter to complete the operation. And similarly, on a TI-30 series of scientific calculators, and if you have another brand of calculators, you would do a similar operation. And the result will be something like 4.149 e to the 11, or 4.149 with a space and then an e, telling us that the answer for e is 4.15 rounded times 10 to the 11 joules. So in general, we enter the prefix, press the exponent key, and then enter the exponent with a plus or minus key, a negative key if necessary. Then you follow it with all of your operations as normal. You may need to use parentheses to make all of that work out properly. I'm sure that you'll be able to do the rest of the practice exercises on your own, and you'll become proficient with scientific notation.